So in a web application, ideally you would never list a ton of items in a single list, right? So if I scroll down here, you can see I have items and items and items and items. And typically you don't want to do this because one, it can be a bad user experience, and two, it's usually bad for performance. But sometimes you don't always have control, whether it's a design issue or a legacy application issue or so on and so forth. Sometimes you just have to render a lot of information. And in cases like that, I'm always looking for ways to maybe squeeze a little bit more information, or rather a little bit more performance when rendering a large volume of information. And one thing I wanted to try was using the IntersectionObserver API in combination with the native NgSwitch directive as a way to defer template bindings in an Angular 11 application. So what I mean is, when we look at this data, we can think of some of this data as being primary or critical, and then some of this data as being secondary. For example, I probably always want the name and the email address to be available on the page, especially if I'm going to do something like hit Command F so that I can search on the page. I want those data points there for the native browser behavior. But something like the location or the last login date, I don't necessarily always need that to be rendered. That could be something I might defer until it is within the viewport of the browser. And that's exactly what this page is doing. And if we look at the elements and we scroll all the way down to the last element, just because it's easy to see, what we can notice is that we have no avatar, and we have the user info, which has the name and email address, but you'll notice that there is no location, last login, or ID here. However, if I now jump to the bottom of the document, you can see that suddenly we have the avatar and we have the meta information here with the location, last login, and ID. Now, if I were to scroll up to the top of the document, you'll see that again, that information disappeared. And in fact, you can see, let's go up to the top here, that as we scroll down, you can see these things are adjusting. And actually, when the elements panel is opened, it's a little bit slow, and you can see those things popping in occasionally. But when the console's open, it's almost completely unnoticeable. You can see the avatar jumping in. It's most noticeable on the page refresh, where you can see that kind of two-layered flash of information. So let's take a look at how this works. We could get pretty complicated, but again, because we already have this NgSwitch directive at our disposal, I wanted to keep this exploration as simple as possible. So instead of building a complex set of intersection-based directives, all I'm doing is creating one attribute directive, which monitors the intersection of the host element with the viewport and exposes that directive through this intersection reference. And then intersection, you can see, has this is intersecting, intersection.isIntersecting value that it exposes, and all we're doing is piping that, so to speak, into the NgSwitch. So when this is true, our NgSwitch cases that have intersection.isIntersecting, and that's just a shorthand for true, just so it makes it a little bit more readable, you can see that the image here, the avatar image, shows when the host element is intersecting, and our metadata here is also using the NgSwitch case to show when the host element is intersecting. And then the other things, like the name and the email address, those are showing all the time. So how does the BN intersection observer directive work? It's doing almost nothing. Essentially, we can see that we have our selector here on the attribute, so it's an attribute directive, and it's exporting this directive instance as intersection, which again, going back to the HTML, that's where we get this. We're saying, get me the intersection reference and store it in this template local variable called intersection, which is then what I'm referencing here. So the intersection observer directive, all it does is on initialization, it creates an intersection observer instance, passes in the callback, which sets that is intersecting flag, which we're exposing on the directive, and then it observes the host element. So we have a 1-to-1 ratio here between host elements and intersection observer instances, which may or may not be a performance issue. I'm not entirely sure about that. But what we can see is because we're only observing a single element ever, even though entries is technically an array, we know that we're only ever dealing with a single item. So we can actually just reference the first entry in that collection, and that's the is intersecting value that we're interested in. And it's either true or false. And that's it. That's all that this directive does, which keeps this exploration really, really simple. Because again, we could have gotten complicated and used a combination of IntersectionObserver based directives, but instead we're just using the lowest hanging fruit here to get a sense of how this might work, and then we're taking that property of intersection and we're piping it into the NgSwitch directive. And now that we have it in the NgSwitch directive, we can use the NgSwitch case and the NgSwitch defaults and so on and so forth the same way that we would normally. And the goal here, again, is to defer some of these bindings, because if you imagine I have maybe a list with hundreds of items in it, and every time I have string concatenation, this adds an additional binding that has to be changed or has to be observed during change detection within our digests. So the more bindings we have on the page, the slower the change detection runs, the more burden is put on the browser CPU processing. So the hope here, and I put hope because I don't know if this actually will make a difference, but the hope here is that by reducing the number of bindings that actually have to be observed during a digest, we'll actually get better performance. But Angular 11 is super fast at this point. I don't even know if it will make much of a difference, but it's been something that's been marinating in the back of my mind, and I finally wanted to play around with it. So again, we can just see that, right, if we jump here, let's look right up in here. And here you can see we have all the metadata, we have the header, the avatar, and the image. And then as I scroll below this, what you'll see is that all that information just disappeared. And it does it asynchronously, so it doesn't block on the main thread. And that's part of where the performance improvement comes from as well. So anyway, just a fun exploration and an interesting technique, I think, maybe to have in the back of my mind should I ever need it.